in this particular case, the view is actually going to be substantially larger in code than the model ever was. But in most realistic cases, the model is the deep part and the big part of the iceberg, and the view is just this tiny little section of code that actually deals with drawing stuff on the screen. I'm going to try and keep this as language neutral as possible, but basically we want our fair enough. So we have a class called the calc view, or whatever your program's thing is going to be called, and it implements the count observer. Now, we're implementing an interface, so we're obeying a formal contract to implement a method. What was the name of the method? Update count or something. Right. First thing we need is obviously the view needs to hold a reference to the controller. We'll just call it C, and we're going to have like a window W button called B and a label called lab or something. For the constructor, we'll just we'll take in a reference to both the controller and the model. So what, obviously, in the last object we built as a controller, we saw how that built its own view for itself. It was given a model, but it built a view. And as the view is constructed, it'll take in a reference to that controller. So we can kind of see how the three separate objects kind of own references to each other in some ways. We're kind of keeping it to an absolute bare minimum because this view does need a reference to the controller in order to be able to communicate with the rest of the program. But we're not going to retain a reference to the model because that would be kind of redundant. If we're communicating through the controller object, then communicating directly with the model object becomes, like, as I said, kind of redundant. I'm really struggling to remember how I actually implemented this. Yeah, so if we say, whatever, our controller C equals controller from there, like it's assigned to our instance variable, and then model dot register observer. And we pass this object itself to the model in order to get that registration thing done. And from here on out, there will be, in that array in the model, there will be one reference to this specific view. And after that, they cease communicating entirely. And obviously we'll do a load of other initialization stuff to get the window and the button and all that kind of stuff on screen, but that's way beyond the scope of what we're doing today, and it's not particularly interesting either. So now we're pretty much set up for this stuff to work. One of the major things is when you're setting up the button, you'd add an action listener of some sort so that you'll set it up. Again, it's beyond the scope of what we're doing here, but you set it up so that the controller listens for actions on the button. And you just do that kind of passing down sort of thing. And the last thing we need to really implement is we need to obey this contract that the view kind of swore to obey. Because when the model sees that this thing implements this particular method, it'll obviously send it the messages expecting it, because it has a type count observer, and obviously anything of a given type must respond to the messages that type is expected to respond to. So we'll override the update method from the interface declaration. I think it's called update count. It is brilliant. And all we really need to do, take in an integer or whatever. All we really need to do is something along the lines of label.set text to int. Any questions so far? Is that making any amount of sense? Anyone got any sort of reservations as to how that was done? So if we follow the execution path again, we'll just finish off that sort of thing.